All right. Okay, I believe we are live everywhere. Let me just organize my windows. Close that. And scoot these things over. There we go. Okay, all right. So, it's been like a week or something since last time. My internet cut out the day after I did the previous stream going over the heat method. Because the housing co-op just decided to switch ISP throughout all of the apartments, and my internet just did not work, and it took weirdly long to get that fixed, and so I had to deal with support until Friday, and then I couldn't get anything up and running, and then support closed on Friday, and then it was not open over the weekend, and then on Monday, my sleep schedule, as usual, is bad, so I woke up during lunch, and then the support line was closed over lunch, so it was just a mess. But eventually, I got it working. But yeah, I've sort of haven't done that much on this since last time. The only thing I've been doing is I've been trying to catch up on some linear algebra stuff, probably just like really basic stuff that you learn if you if you ever studied linear algebra, which I never did. And so I've mostly been looking into linear systems and how to solve them, because I just haven't had to do that much, honestly. And so that's what I was looking into on and off. Let me see, I might need to rearrange the screen a little bit, because I believe where is YouTube chat? Okay. And then Twitch chat. Looks fine, I think. Okay. So, oh wait, my camera's mirrored, right? That was from the DDR stream last night. Just a moment. Transform. Flip. There we go. What does your Twitch username mean? AceGikmo. It is every second letter from A to O. And it's a nickname that I gave myself when I was a kid. I think I was like 13 years old. And I was playing Revolt on the PlayStation 1. And I had this like input wheel where you could just like, it was kind of fun typing in names into that input wheel. Like all the letters were arranged in a wheel. So I just pressed X right, X right, X right, and then AceGikmo popped out, and then I used it ever since. And so that's that's the very deep story behind my username. Surprisingly few people use that name. I would have thought that because it's such a consistent pattern, I would have thought that way more people used it, but it's pretty rare. Like it's about as common for bots to use it as it is for humans to use it. Okay, so I was looking at a simpler problem than the full like heat method for geodesics that I'm looking into. So instead of doing that, I wanted to think about how to solve linear systems in general, and I wanted to find like a simple example of one that I could test. And so I was thinking I would solve a Laplace equation, or like a field of values, and then just do the Laplacian on that, or a Poisson equation solve, I guess. And yeah, that's what I wanted to do. So that's the thing that I was just looking into, like how to do that with linear systems and trying to wrap my head around like what does it mean to set up equations for solving it and whatnot. So the idea was basically that I would have, some field or just a texture of some values, right? And I was thinking I would do something like I would have a few points with known values, and then I wanted to fill in the rest using the Poisson equation. So I would fill in some kind of data, like in these cells or something like that. There we go, some data. Then I would have some other data elsewhere. And then the idea with the Poisson equation is that it should basically solve for the smoothest connection of these. Or smoothest is the wrong term to use. The most linear-ish connection between these values across this field. So it would output some kind of gradient of some sort. And so basically what it does is that it kind of creates like a minimal surface. Minimal surfaces are a little bit weird. But the let me get my brush. So there's a concept known as the Laplacian. And if you have a condition where the Laplacian of some function over, let's say, u and v, so it's kind of like some kind of parameterized surface, if the Laplacian of some function equals 0, it means that the surface is known as a minimal surface. And what this is kind of saying, like what the Laplacian is sort of saying here, that should be 0. It should say that the average of all the points around any given point should be 0. So if you sort of imagine like if you sort of imagine a some kind of surface, and then you pick some point on that surface, and then you can sort of imagine a radius around here. You can sort of shrink around this point, and then taking the average of every single point on this boundary, that average should be 0. And if that's the case, then you have something that's known as a minimal surface. And so that's kind of the basics of the Laplacian. It's mostly interesting in for surfaces in 3D. I think you can do it for curves as well in 2D, but I think what's going to happen if you do that is that you just get a, like if you want to connect a set of points and you want the Laplacian to be 0, I think you just get straight lines. I think this is the minimal surface for these 3 points. So it's kind of uninteresting in 2D. Yeah. So basically the neighborhoods of each point approach a disk as the distance gets smaller. Yes, because I believe the Laplacian is defined in terms of the first derivative. So it's kind of like the or no, wait, it's the divergence of the gradient. I forget if that's, no, that's the first derivative, right? I forget. I think didn't I write this down somewhere? Right, it is the second derivative. Yes. Yeah, because it's the divergence of the gradient. So you're doing 2 derivatives there. Yeah. Okay. So if you say that it's supposed to be 0, then you're effectively saying that you want the acceleration to be as close to 0 as possible. And I think the intuition is that the Laplacian is trying to find the most linear connection for various definitions of linear across some field. And so if you have like so if you have something like a let's say you have something like a cylinder, and let's say that the top and bottom are fixed, so you're not going to move those, but the geometry in between, you can treat those as unknowns, and you want to solve to make this surface have a 0 Laplacian, because right now it does not have a 0 Laplacian. So if you then try to make it so that the Laplacian of the function equals 0 everywhere, then what's going to happen is that you end up with a surface that looks kind of like this. Well, I don't know how to draw today. Don't judge my drawings, okay? So it's kind of like soap bubbles. So you can sort of use that as an intuition. So it's trying to sort of minimize. I think it's minimizing surface area in some way, but I feel like this would be more surface area, so I don't think that's a good intuition. It is trying to minimize something. Do you Godot? I haven't used Godot much now. You were the reason I was able to score a full grade in curves and surfaces thanks to the continuity of the splines video. Thank you so much. Oh, hell yeah. I am glad. Okay. How are the cats doing? They're doing fine. They are napping. They're all in cat trees right now. Okay, so I wanted to build a kind of intuition for solving linear systems, because this is just basic math that I just never studied this. And so linear systems is just not something I've done much. So I wanted to like brush up on that. So I wanted to sort of do this kind of thing where you can imagine a texture, and then you have some values at some known points, and then you want to like spread out those. You want to set all the other values to some value that makes it as smooth as possible, with the same kind of Laplacian solve that you're seeing here. Except in this case, it's instead of 3D coordinates for these, it's going to be scalar values for a height field, pretty much. You can sort of imagine a terrain. Or that's the way I imagine it. So if I have some data point up here that's supposed to be a known value, and then some data point here, and some data point there. I don't know. You can sort of imagine a bunch of points on a surface. Or rather, you have a bunch of points, and then you want to kind of fit a surface to this, such that it's some notion of as smooth as possible, given these boundaries, whatever that would be. I don't know what that would be. Some kind of surface. That's what I was having my students do yesterday. Oh, neat. Okay. So then what you're effectively doing is that if you want to solve this thing, you kind of have this problem where you have a bunch of unknown heights, right? Like you don't know the heights at every single point along this particular parameterization, right? But you do know the height of certain points here. So there's some known values and then a lot of unknown values. So all of these circles here are going to be the unknown height values, right? And these are kind of scattered across the whole thing. And so you can solve this as a linear system using the Laplacian. So you kind of have your, if you imagine a given point, there is a discrete Laplacian that that basically kind of takes neighbors and gets like an approximate Laplacian, or yes, an approximate Laplacian value for that specific point. And so that is basically this formula. So can I not move that? Rude. Let me move that. So if you imagine a point in the middle, this point P, then you can get the Laplacian of the function at that point with this formula. So you're basically taking the neighboring points and you're adding them all up. And then you're subtracting 4 times the height at the center point. And then dividing by the grid distance squared, which could just be 1, like if you don't have like a specific unit that you want to use or whatever. Yeah, and so once you've set it up this way, the unknowns here are, well, it could be this as well, but basically, a lot of these points are going to be unknown. Sometimes some of these are known if they're if P is either one of our known points or if it's adjacent to one of our known points. So what we're going to end up with is a bunch of equations. And it's specifically going to be n equations, where n is the number of height samples, or pixels in our case. And you can set that up as an n by n sparse matrix. So if we take this formula, we can set it up as a huge matrix. And this is assuming a 3 by 3 height field, which is a very, very small amount of data. So this is just, we have 3 by 3 height values. So in this case, only some of these are known. In this case that I've done here, I marked only the cell number. Well, I changed the order here, but 3 is known here. And so then you set it up as a linear system. You make it so that the Laplacian is supposed to be 0 for all of these equations, like row by row. But then for the known points, you just kind of set it up to just give you the, I think that's not accurate. Hold on. I should move down. I've been shuffling things around here, so it's a little bit messy. Messy notes. Wait, YouTube channel screen is paused? What? Is it not working? Let me... Okay, there we go. And yes, you can watch this later. It's gonna be up on YouTube. Okay. And so for this row, we kind of just like fill in our known value. And I believe you can just fill in 1 here and then the known value here for whatever. I guess this is the known value 3. Okay, and then you get this. I think it's called the banded sparse linear system, something like that. Especially in this case, because because of the adjacency of all of these cells, you're mostly going to have information along the diagonals, and so you're basically going to get a huge matrix that mostly has information within the diagonal. Yeah. So you can either set it up this way. I vaguely recall that the column should be 0 as well, apart from this one. I might have messed things around too much here. You can either set it up this way, or you can kind of remove the known values from this matrix and instead substitute them into the equations for all of the other rows. Because it's kind of, you don't want to solve for stuff that you already know how to do. It's kind of wasteful to have it in the matrix in the first place. So if you just like pop out the known values, which in this case is 2 and 5, then we're just gonna not include 2 here. Like it would be here, and then 5 would sit here. Yeah. And then once you're here, you basically have an equation where you have a huge matrix. Usually that's denoted A. So it's kind of A times X equals B. And so this is our B. And then you want to solve for X. X is our unknown huge column matrix. And this column matrix contains all of the height values at every point that we want to know, right? Turns out this is an enormous rabbit hole. I was not aware how deep this rabbit hole goes. Holy God. I feel like this is like generations have spent their lives digging into specifically this. Because there are so many ways to solve this particular thing. Also, thank you for the raid. Thornity, thank you for the raid. Yeah, so there's been an enormous amount of energy and thought put into trying to figure out how to solve these things efficiently. Like, it's relatively easy to solve them. Like, there are a lot of procedures you can do. There's something called Gaussian elimination. Stuff like LU decomposition and a bunch of different things. But where it gets complicated is when you want to do it computationally efficiently. That's when it gets wonky. Because then you have to really figure out how to like exactly which method to use for which type of matrix, because there are many different types of matrices, and if the matrix is sparse, in other words, it's mostly zeros, there are shortcuts that you can use to make it a little bit easier. If it's symmetric, in other words, it's equal to its transpose, then you can take a shortcut with that as well. So there's a bunch of different solutions for that. Yeah. And specifically, the this type of matrix that I set up here is a I believe it's called a Laplace matrix, because it's basically the graph Laplacian of the topological connections of all of these values. Yeah, and the Laplace matrix is basically a combination of there was a word for this. There's a combination of the adjacency matrix, which basically just tells you which things are adjacent to other things. So this 1 here basically means that 0 is adjacent to 1. So every single 1 here represents an adjacency connection. So this says that node number 6 is connected to node number 3. And we can see that 6 and 3 are connected because they're adjacent in our case. There are ways to set this up with like general graphs. Like you can do this with any graph. You can have, you know, some nodes that connect to some other nodes in various ways. And so like any polygonal mesh or whatever, you can have nodes connecting to itself. And like all of this has ways of representing itself in an adjacency matrix. But then the Laplace matrix specifically is a combination of the adjacency matrix and the degree matrix. So degree, I believe, is a it says how many things it's connected to. So yeah, if we make this graph, for example, then the degree of this would be 2 for C, it would be 2 for B, it would be 4 for A, 1 for E, and 1 for D. It's just the number of connections. So I think the Laplace matrix is the degree matrix minus the adjacency matrix, and that gives us the Laplace matrix. And so that's when we get this one. This one, I think this one should be inverted. I think these should be positive and these should be negative, but otherwise it's the same. For a grid, this follows a pattern. So this is kind of a special case because we have a grid data, right? It's all connected through a grid. So like topologically, we don't have like a general connected graph like this. So topologically, we rather have something it's okay that it's overlapping. It's fine. Basically, everything is connected like a grid, like this, right? Depending on how we set it up, we might also want to make it like wrap around, so that A would be connected to like F down here, so this connection would loop around to be adjacent to F, kind of like texture wrapping in games. Yeah. So if you have a grid, the Laplace matrix is actually fully deterministic, which is kind of nice, because then we don't actually have to represent this in a huge array, because this is a big array, because the number of entries on one dimension is the total number of entries in our actual space of data. So if you can imagine that our space of data is like, I don't know, 2,000 points of data, this is going to be a 2,000 by 2,000 matrix, which is a lot, right? You don't want to have to create that huge amount of memory footprint. Okay. So you get a similar matrix for natural splines. Yes, that is true. So where was I going with this? Oh yeah, so I was just kind of like, I was just recreationally trying to figure out the patterns that you get depending on the like the adjacency pattern, because it's relatively non-trivial because it depends on the wrapping behavior. So most of what I've done since last time is that I mostly just like made a little wrote a function for the adjacency matrix and the Laplace matrix, and then yeah. So I have this in code now. So if I just want to get the grid Laplacian matrix, I have that readily available. I could just like request the value at 2 and 4 or whatever. Okay. It depends on the kernel. Well, in this case, it's not really a like convolution kernel type of thing. This is more just the topological Laplacian. Can you answer YouTube paid message? Oh yeah. Love your content. May I ask you? Oh yeah, thank you for the $10, Deepfield. May I ask why Unity and not some other engine, Unreal, Lumberyard, etc.? Just curious. Keep it up. Your learning videos are relaxing to me and help me through the day. Hell yeah, I am glad. I mean, it's mostly just because that's what I have experience with, and I have a lot of projects in Unity. That's pretty much it. I have used Unreal before when I did a few projects. Not many personal projects, so that's mostly been freelance work, but I've used Unreal before. It's pretty nice, but I don't know. I like Unity. I like C#. Okay. Right. Where I was gonna go with this was that I wanted to just try this. I wanted to try my code, just to like make sure that I got this right and that my solver is working, because I did implement one type of solver that I've already forgotten the name of. But let me open Unity. I think I implemented it in a different project because why not? Why not make things more complicated? It's really unintuitive to me, the way that a lot of these solvers are set up. I don't know why, but for some reason this structure just doesn't make sense to me. I guess it's like it's useful. And maybe it's because you can set it up similar to the way that you would write a set of linear equations. But I feel like x should be isolated to one side because that's the thing we actually care about solving for. And so I don't know, it feels like it feels like this wants to be shuffled around and simplified, you know? I just want to change this to like a inverse instead, and like we should solve for x like this, right? I don't know. It feels weird to me. I don't know if it's convention or if there's like a deeper reason for this order, but math nerd, thank you. It's because not all A's are invertible. Yeah. I suppose. Still feel like there should be some better way of writing this. I guess it is kind of more like, I guess it is actually kind of more like a root solve, right? In which case, I would prefer the equals 0 type of thing. Like, I would prefer this. Yeah, I guess it is more similar to root solving than just like a simple like solving for x type of deal. Yeah, inverting matrices is like a whole thing I've also noticed. Why is there a dot here? What's the model of the drawing tablet? It is a Wacom Intuos Medium, I think. I believe. Okay. Do I want to do I want to test this? I think I want to test this. I want to test this on a texture first and then see how that plays out. And yeah, I don't know if I need to implement this on the GPU, but I am going to have to do that eventually. Or maybe I don't have to actually. But it would be nice to parallelize it regardless, even if I do it on the CPU. Safe mode? We ignore safe mode. That's not nice. Yeah, well, one of the things that I was like trying to figure out just reading about solving linear systems is specifically that I would prefer a matrix inversion that I can parallelize on the GPU. And that was surprisingly difficult to find good information on. Or maybe I was just looking in the wrong places. Okay, what kind of error did I plop in? Oh yeah, wait, hold on. Let me first check anything. I'm so excited right now. Wait, what? What are you excited about? I'm glad, but let me just double check. Scroll. Wait, is the stream gone? Hold on. Testing 1, 2. We are dropping frames. Let me know when it seems fine. Oh, is it super dead? Video's lagging. Okay, so is audio fine, but the video is lagging? Is that it? Okay. Why is it so bad? We're back? Are we fine now? Looks like it's fine. Cool. Neat. Was it because I was opening Writer? Okay. I blame excited guy. Oh no. But it's good to be excited. What encoder are you using? I forget. Whatever the NVIDIA one is, the GPU thing. Yeah. NVENC H264. Okay, sorry. Let me bring back the code. Okay. Let's see. How do we test this in the best way? I guess I set up a like a texture, and then I shove colors into it from a native array, I think. I think that's the way to do it, just for testing. What? Why does my YouTube chat keep pausing? What? Excuse me? Refresh? Okay. You probably want to have some control points that you can move around. Yeah. Do I make a height field? I don't know, like, I don't know how high resolution I can make this. Like, it feels kind of rough to solve a matrix for like a 1K texture. So what's that going to be? That's going to be like, that's a 1 million by 1 million matrix. But I guess if we never represent that matrix in a data structure, it's probably fine. Yeah, that's fine. Or no, wait, we're still gonna need... Or wait, am I stupid? Yeah, no, that would be... I would still need those 1 million values for the actual... Yeah, I would still need those million values, just not the million by million, you know? Yeah. Because this was a 3 by 3, which creates a 9 by 9 in total. But this matrix on the left, we never have to represent this in code. We don't have to store that data, but we do need to store this data. So this data would be, those would be the actual height values, which I guess those just live in the texture. So we're going to need that regardless. That's just texture data. And we don't actually have to store this in an array either. I guess that could just be like a dictionary. If we don't have that many known values, we can just do a lookup there. Or we could just make it a native array. It's fine. It's not going to be slow. I don't know why I'm even worried about speed, because I'm just testing this. Okay. I do kind of wish there was some slightly nicer way to just like draw something, like drawing a height field or something. Kind of wish I had like a utility function for that kind of stuff. Okay, so I guess, let's see, how would we do this? I guess we would go to on enable, and we're going to create some kind of texture. No idea what's going on, but I almost had a heart attack thinking you're streaming from my room. I'm not streaming from your room. That would be kind of weird. The same wall color and same set of shelves. Nice. Okay, so I think what I want to do is I'm gonna grab. I feel so risky to do like a high resolution texture, but maybe it's fine. I don't know. I'm trying to figure out like is it ethical to use a like 1K texture for this? But it really should be fine. Computers are fast. This should be fine. It just looks so big when I write it out like this. Okay. Oh, no, wait, is it header? I forget. I don't know how to type anymore. I just don't. Okay, so new texture. Let's not make it dynamic, actually. It's going to be annoying. Let's say width. Is the matrix size dependent on the local topology or on the overall number of pixels? It is the number of pixels. Yeah, the matrix is just every single data point by every single data point. So if you have a 3x3 texture with your data, you have 9 data points. So then it would be a 9x9 matrix for the adjacency matrix or the Laplace matrix. So this would be the size of the Laplace matrix if you have a 3x3 grid. Okay, we are creating a texture. Format. Geez. I feel like anytime I use anything except for the like standard stuff, it usually doesn't work, and then I have to try to figure out why. MIP count 0. Okay. Then we need. Where's on disable? Do we not have an on disable? Let me just scoot. This was also my test stuff. Everything totally works. I don't think I have to test anything anymore. Let's move this to the top. Okay, we need an on disable. Then we need to destroy immediate. I think we should set the hide flags on this as well. Don't save. Okay, cool. We got a texture, and then we need... How do we set this up? Do I make a... Maybe just a button to solve it or something? Or I solve it on enable, like right after creating it. That probably works too. Okay, so how do we... I think I started setting up a way to provide, yeah, known values. So I would like manually just enter a few known values. So then basically the texture in this case is going to be the x in the matrix equation. So this is the data that's in the texture, I believe. I think. The one thing that I haven't added yet, though, is the ability to have known values. So I just have the Laplace matrix on its own. So I do need to have some way to like add exceptions to this. I guess I feel like I should flip these, right? Because I kind of want to have the known values in the actual array here. Yeah, I think I can just flip these two, right? Maybe? Or would I be like messing up the solver? I feel like there's a sign error that might creep in here. Or maybe it's already here. May I ask if you want to solve on a triangular mesh or a regular Euclidean mesh? In this case, I'm just solving it on a grid. So right now there's no mesh involved, but down the line, I'm going to do it on a mesh. So the end goal is to implement the heat method on a triangular mesh or polygonal mesh specifically. But right now I'm just looking into linear systems because I just haven't done that much. Yeah. Okay, but the only thing that this whole line, the only thing that this says is one. Is it one times one equals this? That doesn't make any sense. This is just wrong, right? I'm guessing this should be here as well, right? Yeah, this is the way it's supposed to be. This makes sense to me. Yeah, because you kind of take the whole thing, squish it into it, and you would get F2. Yes. Okay. Yeah. Cool. Now I'm caught up to what's going on. I am using an iterative solver. So I implemented the actual solver. So that's, I have one of those. It is the, what's it called? Conjugate gradient. That's the one that I implemented. Here. So conjugate gradient, I believe, only works on positive definite matrices. Which I think positive definite, what does it mean? It was something like the diagonals are non-zero and it is symmetric, right? Symmetric positive definite? Okay, I was a little bit confused about that, because it seemed like, in a lot of the stuff that I read, it seems like whenever people said positive definite, they were assuming that it was also symmetric. So like, is there a difference between positive definite versus symmetric positive definite, or? There's a difference. What is that difference? Wait, what? I don't know what the syntax is there. The a to the power of t, or what is the little wedge? Is that power? Transpose? Oh, yeah, right. X is a vector. Right. Okay. Well, my note, I wrote that it was at least positive semi-definite. I forget what semi-definite is. Is that like greater than or equal to 0 instead of greater than 0? Greater or equal. Okay. Okay, first I should just make sure that this works. So how do we do this? I think what we do is that we just create a native array. It might not accept a native array of double. We'll see what happens. I'll start with a double. So this would be our X matrix. Let's see. Okay, so size would be the square of that, and then allocator, it would just be temp, and then clear memory. Yes. So I think, yeah, actually, let's just wrap this in our matrix. Or no, I'll just add the matrix separately. So this would be the data. And then I got the native matrix. I want a square matrix. And then we use X data. Okay. And then we do some computation. And then we assign this to the texture. So set pixel data. MIP level 0. Start index 0. Yeah. And then we might need to do text.apply for this to be uploaded to the GPU, I think. Okay. So let's set one of the values of this matrix to some value. Everything else is going to be 0. And and then just see if it works, I suppose. Think. How does a Laplacian matrix relate to the Laplacian matrix? The connection. Wait. How does X relate to X? A Laplacian transform. So there's something known as the graph Laplacian. I don't know if this is the same as the Laplace-Beltrami operator. But I believe it's the Laplace. Yeah. Yeah, exactly. So this is specifically for graphs. Very bright Wikipedia. Oh yeah, wait, there is a dark mode. Although I guess dark mode sometimes has equations disappear in darkness. But yeah, this is the Laplacian matrix. So it's a combination of the degree of every node in the graph, which is the number of outgoing edges. And then you have the adjacency matrix, which basically just tells you which pair is connected. Then the Laplacian matrix is a connection, or is a combination of those two. So it's the degree minus the adjacency. Yeah. Have you looked into intrinsic triangulations and intrinsic Delaunay? I've looked into it, yes, but I haven't used it myself yet. So, okay, so this. Oh yeah, I wanted to add a mesh to this, otherwise we can't see it. Okay. We need some kind of material. Where is it? Run a shader? No. Wait, render material. Material. There we go. And mesh. Do I have... Oh my god, I have a tessellated plane. Hell yeah. I was worried I didn't have that in this project. Neat. Okay. So now we have a plane and we have a material, but we're not assigning any values to it. So we need to do that. I suspect that this is not going to work. It's going to look weird. Oh yeah, so we apply to the GPU, and then we need to assign it to the material. You know what? Shared material. I'm gonna do it. I'm gonna modify assets. There's nothing you can do about it. Then, oh yeah, I have a bunch of errors. Why do I have errors? Oh yeah, because I was just left that hanging. What did I do here? I'm missing grid size. Oh, right. Okay. But then sign should also be here. Okay, so this is basically a data structure for the grid Laplacian. So the special case where you have a grid and everything is connected like a grid. which we're going to use for the textures. Gotta go, but I had a lovely time. Thanks for joining. Good luck with the program. But thank you. Posture check. I don't know. It's alright. It's not that good. Okay. Highly recommend Nicholas Sharp's PhD thesis on mesh processing with intrinsic triangulations. Yeah, I've read a bunch about it, but that's like, it's so beyond where I am right now, so I don't really have a use for it at the moment. But if I do have a need for it, I'm gonna look into it by then. We shall see. Okay. So did this just not work, or hold on? Did I actually get an error there? Not implemented exception. Really? Do you like my function? Okay. Why is there not a built-in integer square root in C#? It really bothers me. This is basically just square root. But it's for integers. Because like, yeah, I guess I could just use double square root, probably. But it feels so wasteful. There has, like, whatever. Like, it just doesn't feel right to use a double for square root. I don't think you agree with the optimize later principle. No, it's, well, I mean, in practice, quite often, yes. But I have optimization brain, and I get, like, itchy if it's not optimized. I don't know. It's probably fine to just do this, but it bothers me. Wait. Oh no, I'm not returning anything. Fine. I guess. Okay. Okay. We have a block of black. Do we have any kind of... Is there any data in this texture at all? Or did it... Is there something down there? No, nobody's quite sure. I only set 1 pixel, so it's not very easy to spot. But I think this will just not work. I think I have to give it data in the form of colors. Unless I use a texture format. That is just 1 channel. I feel like I should be able to use rfloat. Why is it unhappy? What did I do wrong? Because I need texture creation flags. Or texture creation flags dot. I think I just want none. What? What? How do you want me to disambiguate this then? Because I need to cast it? What? Okay. Wait, why not just graphics format? .rflit. Or no? Okay. What is this constructor setup? This is the most confusing constructor setup I've ever seen. What is happening? Can I... Hello? Oh, wait. MIP chain linear. Oh, okay. False? Linear? Well, should probably be linear because it's data. Okay. But this is an array of doubles, not float. So I wonder how that's gonna go. Object at index 0 is null. Excuse me? Oh, that might have been because I have had the texture focused, but it's deleted now. Okay, just for testing, I'm going to make this smaller. We're going to do a 64 by 64 so that we can see what's going on. You know what? And I also... can you set like clamp stuff here? Text. Wrapping, wrap mode. Clamp, yes. And filter, we want to use point. Well, that looks like a pixel. Looks like we might be getting somewhere. Look at that. Wow. Wait, why does this work? Because I'm setting a double. Oh, I guess it could be because the remaining bits are 0. What? Did it import the wrong random? It did. Value? But that's a float, that's not a double. How do I get a random double? Okay, system random. New random, seed. Next double, there we go. Okay, cool. Although I specifically want a double from 0 to 1. How random is next double, actually? Okay, C#, next double. Is it from 0 to 1? Oh, it is from 0 to 1. Okay. Thank you for the sub, Sakamino. This looks like it's suspiciously close to 1. Did we actually set a random value here? I don't trust this. This feels weird. Let's set it to 0.5. If you clamp, the value will be 1 anyway, right? But I'm not clamping right now. Okay. Is double unity tag in your stream? That is true. Literally unplayable. I fixed it now. Wrap mode is just how texture sampling is working. So if you sample the texture outside of the texture, instead of clamping, it can start sampling from the start. So wrap mode is just like how it samples the texture. It has nothing to do with the like output values after sampling. It is a little bit weird that this is not actually changing it though. Let me just make sure that it's actually updating the texture whenever I recompile, because it might be that I'm just looking at the same old texture. Okay, so it is actually moving. Okay. Okay, so I suspect that this is just because I'm sending a native array of doubles into something that I think needs floats. And I would suspect that it's probably just taken the double and kind of chopping the bits in half and interpreting one half as a float and the other half also as a float. So I thought that by making a random number, I would be seeing 2 pixels light up, but maybe my mental model of what doubles look like is off. Okay. So then the question is, do I... Let's see. Can I like cast somehow? That's an IEnumerable. That feels strange. Yeah, I wonder if I should just like change all of my matrices to use floats instead of doubles. That might be easier. A little bit worried about precision, but maybe that's okay. Float. There we go. Refactor done. Almost. Almost. Give me a moment. Almost. Hold on. Just a few. Oh shit. Shit. There we go. This is fine. Why can't doubles float? I don't know if you're making a joke or if you're asking why. Why it doesn't work passing a native array of doubles. Wait, Twitch chat on the stream is cut off a bit. Is it? Oh yeah. The width is cutting out. Hold on. Thank you. I recently changed font size, and so I'm a web dev. I only know number. Oh god, JavaScript. I did not like JavaScript. Good lord. It was actually kind of painful to work with. Okay. Half brightness on this pixel, please. Yes, that works. That works. Cool. Okay. Okay. We're making progress. So the reason I'm guessing this didn't work is because whenever you're sending a native array in Unity, it's sort of like a shorthand for here's a chunk of bytes in memory. And a float is 32-bit, but a double is 64-bit. But I think no matter what type of native array I use and set pixel data, it's going to interpret those bits as if they were floats, even though they might not be floats. And so I think that was just there was like a conversion there that didn't work out. But this looks good. This looks correct. Just to make sure, let me just make sure I got this right. Yeah. Neat. Okay. What is next? I believe the thing that we should do next is that I should pass in the known values. It would be really cool to make this interactive. I think I want to make it interactive. It's going to be so much nicer that way. Okay, so I'm going to make I think I'm just going to make it so that child objects are the known values. And so then I can kind of just drag this around to like move all the values, and then the height of this is going to be the actual number assigned to it. I think that's what I'm going to do. So how do I do this? It would be like an enumerable of a tuple of int2 and float for the value, I think. Yeah. Would it be possible to reconstruct the double by combining the two 32-bit parts on read? I mean, yeah, it would be, but then I would need to like I would need to sample the texture twice in the shader, which feels a little bit annoying. Why not use a linear algebra library? Because I wanted to learn it myself. I will potentially end up using a library down the line. But there's also the fact that I do want it to fit into Unity's native array for performance. So I don't know how directly I can use libraries. And especially because Unity is kind of stuck on older C# versions. So I'm not sure how that's going to go, but okay. For I in transform.childCount yield return transform no, get child, and then we've got, how big is this? I need some dimensions. Let's just add some cubes. Oh, hold on. Okay. Okay, so it's basically 1 by 1. So it's 1 by 1, but it's centered. Okay. And it's along X and Z. Weird choice past me for selecting this orientation of this plane, but that's okay. I'll just have to live with that. So then I just need the local position, but remapped. Let's see, I want to map it from negative 0.5. I think it's just plus 0.5, right? Okay, why not? What did I do wrong? Do I need to do XY? Oh wait. It's so annoying that like Unity didn't make like implicit conversions between their old vector 3 and the new float 3s. Okay, so this will give me a value from 0 to 1 for the coordinate, and then I just need to yeah, I do need the grid coordinates there. So then I would just grab this, I believe. No point in learning anything anymore. Just ask Claude to do it. You can go do that if you want to. But I do not want to do that. Okay. Can you define your own data types in Unity C#? Yes, you can. Okay, so we are returning this times the no, it's p dot xy times the width, and then cast to int 2. No, okay, well, round to int 2. And then do I want to do something else with this? I don't think I need to. Or no, I need to clamp this. Specifically this, or no, wait. Wait, why is there no, have I not done the extension method for that yet? Okay. Fine. I have like a math library that I'm working on. That's kind of half finished in this project. So a lot of my functions are a little bit half-baked. Like this one you shouldn't have to specify the rounding direction. So I just don't have a default on it. They already had a math library? Yeah. I mean, it is the one that I have on GitHub. I've just started doing a big refactor on it. Okay, and then the known value would be just the height. Oh wait, I need to take the axes into account. So x and z is what I should be using here. So I should flip these. And instead of xy, it should be xz, and then the y coordinate should be, oh yeah, it should be y, I believe, or the height. Okay. Why is this sad? Does it not round to... What? I don't like round functions that don't cast to the actual data type. Oh wait, there's no point in saturating the let's see, value to clamp, lower bound, upper bound. So 0 and this -1, I believe. Okay. Wow, known values. I do want to move the update texture stuff to a separate function so we can repeat it. Or recalculate test field. I don't know. Something like that. Which is basically what we're doing with all of these. And then I guess that can live out here. That's okay. And then this would just be x.raw data. Not sure how your solver is written, but the Laplacian is negative, semi-definite, negative 4 on the diagonal. Instead of ax equals b, you'll have to solve negative a. Right. Yeah. I think that's what I've been doing. I do have a sign field specifically for that. For the Laplace matrix. Oh wait, where'd it go? Excuse me? Excuse me? Oh yeah, here, this one. So this one has a sign. So if I want to flip it, I can just do that. Okay, so instead of just passing these manually, I am going to iterate over the known values. And then, so this is going to be the texel, and then we have the value. And so we're just going to scoot this, and we're going to do texel dot y, because matrix notation is annoying, and then texel dot x equals value. Okay. All right. Question is, how do I make this auto update? Oh yeah, I think there's a callback for like this one. Yeah. But that's not when I move it though. This is probably a topological change. Yeah. Hmm. Hmm. Or I can just say, fuck it. Toss it into an update loop. Object disposed? Oh yeah, wait. Yes, that makes sense. Yes, because it's a temporary native array. I will simply make it persistent. And then we dispose of it. I thought. X.raw data dispose. Wild tail appeared. True. This is Salad. My son. He's napping here nearby. Okay, so is this working? Or did it... Oh no, wait, it probably only worked once. Because of the dispose situation. Okay, what if I redo it now? Is it fine now? Oh. I've just created the worst image editor in human history. Why though? It's probably just the UVs. It's got to be the UVs on the mesh. That's probably it. That's probably it. I guess I can just check. Shader. Wait. What? Okay. Oh, that does work. Okay. That would do it. Those UVs were not the way that I expected them to be. Okay. I don't like this mesh. But I guess, I mean, I can probably just flip it until I'm happy. That's more what I would expect. We also have the texture. I just deleted that line. I don't know if there's anything specific in URP that you have to do. I pretty much never use this sample texture 2D function, or the macro. But okay. Okay, and then swap that out. Where did I put it? Custom. Custom, custom, custom. UED play. Okay. I assume the heat map is stored as a texture. It's complicated. Wait, why does this not? Why does it still look as if the UV is at the top there? Hold on. I am using that shader, yeah. Why is it flipped? I thought oh wait. I undid my flip. That's why. There we go, thank you. Look at that. Look at these known values. Draw a hornet? I don't think this painting tool is is good enough to do that. Unfortunately, haven't gotten that far yet. Thor! Hey! What's up? Hello? Come on, buddy. Hey, what's up, Thor? Come on. No. Okay. I'm just gonna go check on Thor. I don't know if you heard Thor, but wait. Buddy. Hello. What's up? Hey. Ooh. Okay. Thor seems okay. Hey, buddy. It was a bit of a different yell. He usually doesn't yell quite like that, so I was a little bit concerned. But he seems okay. Sometimes he does a weird yell after waking up. I don't know if he's like, can cats have nightmares? I don't actually know. I presume they can. Okay. So there's a few things we need to fix here. So one, I need to clear the values before setting these known values. So I wonder if there is like a clear type of thing. unsafe utility. No. Do I have to like iterate through the whole thing? That seems a little bit annoying, but like why is there not a clear? Oh yeah, because clear depends on the data type. That's probably why. Although I feel like setting all bits to 0 should be like a thing. Unity native array set bits to 0. Will not really? There has to be, right? Like a set mem set re eh. That's native array extensions. Wow. Guess I can also make a set all. Okay, now we can do that. Now we've got the ability. X dot. Where's my function? What? What? It's a native array, right? Or wait, X is my... oh yeah, X is my matrix. Raw data is inside of that one. There we go. Okay. Yeah, set all to 0. Look at that. Hi, I'm a 16-year-old programmer. Can you give me any tips for mastering C++? Right now I use Arch Linux with NVim and C++. I'm not super into C++, so I can't give you like many like C++ specific types of advice. But in general, like, I don't know, practice makes perfect. If you use C++ a lot, if you have actual projects that you're working on that's written in C++, that's, for me, that's usually the fastest way to learn stuff, where like you find projects where you have to make use of the thing that you want to learn. That's usually how I do it. Look at that. Look at that. Cool. We now have a nice way to plop out little known data points. I hate my mouse. My mouse is dying. What are we working on? Right now I'm just testing a bunch of linear system stuff. So I'm gonna make a surface, and I'm gonna have a few known points on this surface, and then we're gonna solve for the rest of the surface. That's why. That's the thing that I'm working on. And it's gonna build up to eventually implementing the heat equation on 3D meshes in order to get geodesic distance on that mesh. Yeah, but that's further ahead. Okay, so now that we got those points, what do we do next? We need to do the actual solving, I think, right? I think we're closing in. Oh wait, no, actually, you know what? I'm gonna make it an actual height field because right now it's flat. I don't want it to be flat. So let's go to let's see, it would be in here. And it would be along the y-axis, I guess. Position OS. Object space. That's gotta be it. Okay. Good. So I wanna, yeah, I wanna modify this one. Dot y plus equals. How are you motivated to learn and code things by hand? How are you not tempted to use Claude Code? I'm not entirely sure how to like answer that question. There's multiple answers, and there's multiple answers for that. But to me, it's like I enjoy the process of learning, and I enjoy the process of writing code, and I value understanding my code base. And if I use an AI, I'm skipping all of that, and that's not nice. So it's kind of like, I don't know. Like sometimes it feels like someone's asking me like, hey, if you like why are you going to a restaurant and eating the entire meal yourself? Like why wouldn't you just have someone else do that? Like it takes so long. It would be way more efficient if someone else could do that for you. And it's like, I mean, I want to have this meal, right? So but I guess it's like if you just see code as a means to an end, then I can see why you would like AI. And if you don't care about knowing your code base, I can see why you would like AI. Okay, I was going to set the y coordinate to the value. Feel like I need to use text2d lot. I don't know if this macro somehow automatically does that for the vertex shader. Oh wait, I'm dumb. There we go. Okay. What? I don't have sampler 2D. Probably because, yeah, okay. That is not what I expected. Why? Excuse me? Why is this not working? Why is it all at the same height? Or did I mess up the order of these? Pretty sure it should be in that order. No. Yeah. Why is it not working? Excuse me? Excuse me? Is value a special word of some sort? Sample texture, grab the right component, add to object space Y. Why are they all at the same height? Okay, if I set it all to 1, they're all up there. Set it all to 0, all down there. So why? What? Okay, let's just try adding the x-coordinate of the UVs. Yeah, that looks correct. Y-coordinate, that looks correct, I think, yes. So why is it failing to sample the texture? The heck? How is that possible? It's not getting the values. Actually, what even is this value? It's at like a weird height. I think these should be 0 because this is just picking the mid level, right? I don't think there's anything weird with these. Okay, is there anything magic in this macro? Okay, is there a sample texture 2D LOD? Yes. Do they want me to use this one? I haven't written shaders in for like URP pipelines in Unity for a while. Texture name, sampler name, UV, and LOD. Texture name, sampler name, UV, and LOD. Oh wait, I should have used There we go. Okay, is that the way to go? Apparently, okay. Alright, I have no idea why the first one didn't work. But now it does. Cool. It's a little bit cursed that it's bleeding down the edges of one of them. Yeah, Unity, well, CG is kind of like, it's a little bit legacy. In practice, it's HLSL. But it started out being CG, and now I think it's HLSL, but I think at some point it was kind of a weird mix. It's weird that you have to use this macro, though. In the default render pipeline, you didn't have to use that. I'm guessing there is a way to just dig into whatever. Platform, sample LOD, texture, sample level. Okay. I wasn't aware of that. Sure. Cool. All right. So now the goal is to move this entire surface to fit these data points, but try to minimize the Laplacian. So we basically want a minimal surface that passes through all of these points. Yeah, and that's what we're going to use the matrix solver for. And I'm very curious if this is going to work. I think it's going to work. Unless I'm going to like mess up some signs somewhere, which I probably will. Okay. Do you have the thing that will render the surface setup already? I mean, this is the surface that's rendering, right? So all I need to do is set this data to whatever it is that I want to set it to. Which we are going to do in here. So, how is this going to work? We have a matrix. We have a matrix X. And then we have the solver. Which is this thing. Thor! What's up, buddy? Yeah? Okay, I'm gonna check in on Thor. Hold on. I'm a little bit worried about Thor. Like Thor does yell every now and then. He does that. But this was a different yell. And it's not like I'm not the only one who reacted to it, but my other cats also reacted as if it was like a anomalous meow. I'm a little bit worried about the guy. His ears are like flatter than usual. I don't know. I'm gonna have to keep an eye on him. I'm like pretty much always on health duty for Thor because he's very old. He's 17 years old. Yeah, he's looking a little down. He's in one of his favorite spots right now though. And yeah, it looks like he's settling in. Well, he's cleaning himself. That's good. That's a good sign. Yeah, I think he's doing all right. Wonder if he's probably just got like a tummy ache or something. Because he is behaving as if he's in pain. But then he usually doesn't yell when he's in pain. That's the kind of scary part. Okay. How do you check in cats? I know in dogs you gotta check lip licking and hunched back. Honestly, a lot of these things are just intuition at this point. But cats have a tendency to hide their sickness quite a lot. So usually the telltale sign that something's up with your cats is a break in a habit. So if they, especially when it comes to eating and using the litter box. So if he's not using the litter box or if he's not eating, that's a sign that something's wrong. And in this case, it's just kind of a general like lethargic behavior. He's very slow and careful, more than usual. And yeah, and the yell that he did was a very different type of yell, where literally everyone in the household reacted to it, including me. So, yeah, and then they have a tendency to also hide when they're not feeling well. Like they're very slow. They hide under things and they just kind of want to be left alone. But yeah. And there's also I think if they're in pain, they're also usually loafed. They very rarely like lie down comfortably on the side or like flop or whatever. I think if they're tense or in pain, they tend to just kind of loaf in place instead. And also his ears were very down, but I don't know if that means anything. But I don't think they're usually in airplane mode. But yeah. Yeah, I'll keep an eye on him. He ate this morning, so that's good. I don't remember the last time we used a litter box though, so I'm gonna have to keep an eye on that. Okay. what were we gonna do? Oh yeah, we're gonna do something along these lines. And that. Just gonna copy my old setup. Okay, solve for x. Wow. So now x is our column matrix of values that we want. Oh wait. Hold on. I made it a square matrix. I'm just gonna change it to a column matrix. Okay. And then we've got B, which is, so what is B? That's going to be the target values, right? So that's going to be this whole thing. That's a nice way to represent that. I feel like I should make like a wrapper around a dictionary or something. Yeah, like a matrix wrapper around a dictionary. So we got our column matrix. And I think we're just going to make another data type. That's a sparse column matrix. And then I guess we're not really going to be using the, this is just going to be an I matrix actually. Because we're not going to use the native array stuff. But we will have some kind of value for size. So that's going to be the number of rows. Oh, you know what? Is square should not be false here. I guess if you have a column matrix with one row, it is actually a square matrix, so. Okay. So let's see. We've got the size should be passed in there. And then how do I want to store this? I guess it should be a because it's sparse. I think it's just going to be a dictionary of the coordinates and the actual values, which is flipped. Oh wait, this is a struct. That feels weird. I feel like this should be a class in this case. Could be that when you stream, he's not used to the constant noise in the background. Nah, I don't think so. I mean, they're all used to me streaming, so. What source control do you use? I use Git. Oh, Cinemachine? I have not used Cinemachine, so I don't know how that works. So maybe it's worth it, maybe not. Okay. forget what the I forget what the access pattern, or like if it throws, if you try to access access in dictionaries. So I want this to return 0. But I think there's, if actually, is there like a get or default? Yeah, get value or default. Perfect. That's exactly what I want. Yeah. Cool, cool. Perfect. And then just do that. Oh yeah, wait, why do I even have an int 2? Because it's a column matrix. I just need the row. Oh, new int? I don't think we need to do a new int. That's probably unnecessary. Why are we implementing our own sparse array types rather than use one of the popular implementations? Because I want to. Okay, this is sparse matrix column. There we go. Should size be public? I don't know. I don't know. 17 cat years? How many human years is that? I don't know what people usually use for conversion. But 20 years is pretty old. Most what is the lifespan of cats? It is pretty high. I think it's like 20 something. 22 is average lifespan. I would guess is probably around 20. I would guess. I could be wrong though. But life expectancy is 10 years, I think, which is kind of sad. Okay, I think that's is that all we need? I feel like I'm missing something. Is this really it? Oh wait, this line is gonna throw, so I should what? It undid to the wrong state. Yeah, okay. Maths are going pretty alright. We'll see if it works once I run it. Cool. Okay, so B is going to be a sparse column matrix. And how many entries do we have? That would be, what did I call it? Yeah, that one. The number of pixels. So we're going to pass that in there. What's happening here? Oh yeah, this was probably an array. Yeah, we don't need this anymore. This is where we need the Laplacian thing. Yeah. Grid width, which I think is the that value. We're gonna have to play around with the signs of that whole thing. So we just implement the index operator and all the other matrix methods just work. Yeah, that's the idea. So that you can just pass matrix-like objects into all of these functions. Okay, so this is not fully done because when we set it up this way, there's a few things we need to do. We need to set these values, the kind of exceptions, and we need to set these whole things. So how would I do that? I feel like that would be like kind of like another matrix wrapper. How would I want to define that data type? I guess it would be extending from the Laplacian matrix type. And then I probably have a similar like dictionary setup where I just have a dictionary of exceptional values, or no, just a hash set actually. And then all of those, like if they're present, they just get nuked when reading out the data, I guess. Yeah. I don't know what to call that data type. Like a Laplacian with holes. Exception, I don't know. Or if I should have like a compound. You know, it almost feels like I should have like a no, that's not going to work. Or maybe like a matrix stack or layering system or something where like I have two matrices, and if one of them has a value that's overriding it, then it picks the overridden value, otherwise it falls back to another matrix. Like an override type of thing. And then this takes two matrices. Like copy on write. There's no writing here. This is just reading. I would also need a function for like when it would use one over the other. Like a bit mask? Something like that, yeah. No, this shouldn't even be a data type. This is a function. I'm just describing a function. Yeah, this should just be a function. Yeah. Okay. That's it. This is gonna be a function. I really need to separate out my matrix math stuff. You know what? I'm going to do that right now. Move over here. There we go. So I guess it's public, static, float, sample. No, it's more like an over operator where yeah. Yeah. It's kind of like layers in Photoshop. And then the predicate is just basically the opacity. It's the opacity function. Oh, and then we need the coordinate. Yeah. Does this make sense at all, or is this weird? There is kind of an argument to be made that this doesn't really have to be its own function. Like, this could literally just have floats in it. Maybe. Nah, I think this is fine. We'll see when it becomes stupid. Okay. If opacity incorrect, why did the AI autofill something that is clearly not possible? Then we return above, row, column. You know what? Wow. No, I kind of want to be able to read it, actually. Okay, we've got an over operator. So now the opacity function is going to be carrying a lot here, but that's fine. Or no, wait, yeah, hold on. The reason I wanted it to be a type is because then I can pass it into the solver. That's the only reason I wanted it to be a type. Okay, well, it simplifies the type. So I guess I can still make a type for it. Why not create a new matrix? Because this matrix would be enormous, and all of that data is going to be a huge waste of space. It would contain like millions of entries, which is a lot. So because this matrix can be like directly evaluated with a few exceptions, it's kind of nicer to have the directly evaluated matrix, and then I can just like on read, I check if there's an exception there. So that's what I'm doing with this. Did I have something? Yeah, there we go. Okay, wait, why is this? Oh yeah, because it's an interface. You know what? It can be a class. It can be a class. That's okay. Is square. Kind of depends on how we layer these things. I guess it would be like the maximum of below dot, or no, wait. I don't even know how this would work. How do I even handle overlaps? I don't even use this field, I just have this field. You know what? Below is going to be the representative one. Since when do you use AI? What do you mean? Oh, do you mean like the autocomplete? Sometimes the writer likes to re-enable that. And sometimes it is, sometimes the like one-liner autocomplete is useful, and sometimes it's annoying. So, I don't know. Okay. So I'm probably just gonna use below as the, yeah, I'm gonna assume that that one is gonna be the representative here. Okay, so here's where the spicy stuff happens. And this is where we need the predicate as well. So that's going to be the constructor. So we're going to have, actually all three of these are going to be in the constructor. Wait, why is everything public? Don't make it all public. You don't want that. Okay. All right, and this is just going to use the matrix math stuff. Oh, we had a matrix math that was separate from native matrix math. Probably should have moved some of that code out of the native stuff. I'll just move that later. Row, column, below, above, and predicate. Okay. You know what? Is this the type for the Laplacian? Yes, the A matrix. Thanks for bringing this up. It has so many applications. The heat method in general, or? Wait, is it called I matrix layered? That's not how you name non-interfaces. Okay, so our layered matrix is the actual A here. So this is our Laplacian matrix. So below is going to be the Laplacian, and then we're going to have the matrix above, which is honestly just the identity matrix. It's the opacity function that's interesting here, which means I should probably make an identity matrix. This feels illegal somehow. I don't know why. Is the identity matrix square if it's like unspecified size? I guess this is an infinite matrix. This is a finite matrix. You know what? That's, or this is an unbounded rather, right? And we wanna inherit from the unbounded one. Because it only makes sense to ask if a bounded matrix is square. And it only makes sense to ask for the count of entries. But it is possible to sample the unbounded one. Right? So in my opinion, the identity matrix is an unbounded matrix where when you sample it, we get that. Okay. Is that it? Is this the tweet? I mean, I guess it's just a new matrix identity. just a single thing that we then dispose later. Oh yeah, because right. Okay, I'm gonna have to rewrite a bunch of types now. So this should be I matrix, and this should be I matrix bounded. I'm gonna rename this. And then where, let's see, layered matrix should actually, the layered thing should also just be an I matrix. You know? We don't want sizes. Okay, and our over operator should also just be I matrix. Cool. And then our solver this one has a specific one here. Residual. I don't need the number of things in A. I guess I can just use the size of B here. And it should be the number of entries. And then conjugate gradient. I think we can just use an I matrix here as well. Residual. Let's just toss in I matrix. Okay. Multiply. Well, I'm kind of assuming they match the number of entries. So okay. So matrix layered should accept iMatrix. Neat. All right. Wait, did I get it reversed? Below. No. Okay, yeah, that's correct. Cool. So now we need a function. The purpose of this function is basically to say when we sample something, should we return an entry from the Laplacian matrix or should we return the identity matrix? And the identity matrix is the value that we should have in all of the rows and the columns where the data is known, which is this in this case. So the layering is basically just doing this on top in case we are inside of those known values. That's what this layering thing is doing. So L is the Laplacian matrix underneath. And then we have the like crisscross patterns where these are just the identity values. It's just one along the diagonal. That's it. And that depends on the known values in yellow. And so that's what gives us that. So now we just need the function that identifies whether a row is known or not. So I guess it's just going to be a hash set of int2 known values, known coordinates. No, wait. Int, actually. Yes. Yeah. Known entries. Or no, wait, hold on. Yeah, because this is the thing for 3x3 grid. And yeah, okay, that's fine. So I think this would be known values dot known values select let's see, what does that get us? That gets us a tuple. Can you deconstruct tuples in select here? No. Okay, it's kind of like a key value, sort of. Item 1. Not the best name for that, but... Okay, so this is the coordinate as an int2. So then the coordinate, we need the flat version of the coordinate, which is I think I literally have a function for this. Flat index. There we go. And wait. Yeah. No. Hold on. Wait, S? Oh yeah, size. Oh my god, I'm stupid. Okay, known entries. So then our opacity is just going to be row column known entries dot contains, I guess, flat index of an int2 of row and column. I believe that should be it, right? Oh yeah, wait, we need to set the entries of B. Yeah, so I think we've set up this now. This one could probably start uninitialized. No, we actually have set up this as well. We just haven't set up this, which is trivial. So then all we need to do is iterate through the known values. And then set B, let's see, I think we need the flat index here again. The flat index of pixel width, and that should equal value. Yeah, or we assign value to that. I think that's it. Okay. How's chat doing? Chat died. There's no more chat activity anywhere. Everybody was just like, you know what? It's not worth it anymore. She's not even responding to my messages. Hello, Alonsi. Left to read the paper. That's fine. Okay, we don't need to print stuff. Just gonna assume everything's gonna work out great. Hey, Crashlog. Reading the code. I'm sorry you're reading the code. My code is a mess. Okay. Native matrix column. I'm passing in a sparse matrix column. Okay. Can I just use an I matrix? Would that be okay? Let's see, row, column. And then, wait, hold on. I was going to use that for B, not for results. I'm using the stream as coding motivation. Hell yeah. I'm glad to be able to understand what's happening in this code. Just being here for 20 minutes. That's nice. Good. Okay. Okay. I think we are very close to some kind of results. I hope. Let's see, sparse matrix column. We only need to dispose. We don't need to dispose anything actually, because we have a persistent native array. Okay. Theoretically, this should work. Yeah. Theoretically. Are we ready? This is suspicious. This is very suspicious. Should it take this long? Are we in an infinite loop? Will this be running inside a Unity job? Eventually, yeah. Right now, I'm not doing that. I think it's over. It got stuck. Something's not right. I am printing some stuff in here, but it's not per entry, it's per iteration. Unity's memory seems to be fixed. It's not allocating a bunch. What's your assigned residual? Do you mean like the threshold, or? There is a max number of iterations, yeah. Don't know what I actually set it to, though. I set it to n, which is very incorrect. This is the problem. This is deeply incorrect. That's a lot of iterations. That's currently 32 by 32 iterations. Which I think would be the number of iterations to guarantee convergence. But maybe that's probably way too many iterations, right? I feel like it shouldn't have taken this long, though. Like, even if that was the number of iterations, no way it would take this long. You study pure maths? I mean, in my own time, yes, but I'm not like studying at a university or anything. Memory was fine. It was not like increasing. Oh wait, it's gonna get stuck again, right? How long have you been using Unity? Since 2010, probably. 2010 or 2011, somewhere there. What is a rotet? It is it's the working title for my Tetris-like game. I just happen to be doing these things in that project right now. I'm gonna move it over to to half edge once I got everything working. Okay, just setting up all the things that we lost because I didn't save the scene. What happened to the 3D and Unity project? This is for that project. It's just that it's not open in that project right now. Oh my god, did we get stuck again? Really? Why? Yeah, just why? Wait, why is it stuck now? Oh my god. Where did I project? Where did this happen? I recommend just printing solution to simple linear system to validate CG is working. I've already done that. So it is probably elsewhere. Okay, so why are these like projected and on the wrong axis? Okay, I'm just gonna comment out the entire solvers thing. So I suspect it might have just been some of those. No? I didn't change anything with this code though. Why is this not working all of a sudden? What? Why is it not responding to the x-axis anymore? What? Oh. Right. Right. Okay, hold on. That makes sense. Yes. Because this is a flattened matrix. Yeah, so this is actually... This should have thrown. I feel like I should have made this throw instead of just silently fail. That's my bad. Okay. That's better. We got progress. Okay. 2 data points. Save scene, and then everything just disappears. Sure. Okay. Let's also not do this in update. Let's do this manually. Public void recalculate height fields field. Wait, we already have a function that's called literally that. I just want the context menu. Yeah. Okay. How do you find Unity's flexibility in implementing rendering features? Have you ever faced a limitation? Usually it's pretty good. Especially with like the new render pipeline stuff. Like it's a nightmare if you want to support multiple render pipelines at the same time. But if you don't want to do that, it's really flexible. And that's one of the things I really like about Unity, which I haven't done render pipeline stuff for Unreal, but I got the impression that that's pretty locked down. So I really appreciate that about Unity. Okay. Recalculate is now a button. What's a render pipeline in Unity? You can switch between different render pipelines designed for different like quality levels. There's like the old render pipeline. There's a universal render pipeline, which is just the new render pipeline. And then there's one called a high definition render pipeline. The decision to split these up into separate render pipelines has been kind of a controversial thing because it was a nightmare to deal with. And I think they're going to unify them in future versions of Unity. Thank God. But it does let you modify them. It's very open. It's very easy. You can modify all of these in C# and with HLSL. It's great. Okay, so I guess we're ready to test to see if this works. I'm a little nervous. I don't want it to get stuck again. But we did set it to 1 iteration now. And it's not doing it every frame. So it's only going to do it once. That actually looks good. Kinda. Wait, why did it get lowered? Wait, that looks like it just averaged them. Shouldn't this remain fixed? Hold on. Did we forget something here? I feel like it's almost like interpreting these as 0. Some games I like seem to do custom render pipeline. Is it too hard to do such a thing for a solo developer? All of that is going to depend on your experience and whether or not you need it, right? Like most games are not going to require a custom render pipeline. Like stuff like that is like generally you only do that kind of stuff if you really need to. Most people don't have to jump into doing render pipeline stuff. So what is happening here? Oh my god, wait, I'm stupid. Or no, I'm not stupid. I think this is correct. Yeah, I think this is correct. Yeah. Okay, I'm gonna bump iteration count to 2. Just to see if my theory is correct. That it's like, it's just doing like an average of neighboring cells. It really looks like it. It really looks like a straight up averaging. Okay, so what am I doing wrong then? Is it my math that's wrong? Like, am I... The equation in front of me right now, is that actually set up correctly? I feel like it should be, right? Like that should just work out, you know? Unless, like, I feel like it feels like it's overriding this value. But it shouldn't, right? Because it's already satisfied this equation. What are we expecting to see if not an averaging? It's supposed to be an averaging, but the known values should remain fixed. So it should average overall, but keep the fixed points in place. But it doesn't keep them in place. That's the weird thing. Should the top entry of vector B be negative 2f? Wait, negative 2f0? Wait, here? When you say keep in place, do you mean the location or value of the peak? The value of the peak. Super King Tofu. I think that is what the matrix already encodes. Although... Hold on. You might be right, actually. Because there should be 4 entries here. Why is there only 3? Or no, wait, the 4th entry is the one we're solving for, so that does make sense. What's the order of operations with a layered matrix? That is a good thing to double check, I guess. So we have the below matrix and the above matrix. And the predicate. Let's see, we got below, above. So if opacity is true, we get the above matrix, which is the identity matrix, which is correct. That looks fine to me. I guess I haven't like printed the... I guess maybe I could print this just to like double check whether it's correct. Whoa, you stream! Yes, I stream every now and then. Is it weird that your diagonal has different values? No, that is correct, actually. If the known entries contains the coordinates, then you get the identity. Ooh, wait. You are onto something. Yes, I think this is incorrect. Hold on. Hold on. Okay, hold on. So, oh, there's so many different coordinates here. So I think using flat index is incorrect here. I should check if known entries contains row or if it contains the column. I'm pretty sure. Yes, because it's both row and column. Should check for... Yeah. That should actually be it. That would be broken. And now why is this not working? Oh, wait, this should not be there. No, I believe this is correct. I am pretty sure. Let's see. Okay. Okay. Let's press recalculate. You know? Fascinating. I sort of expected some kind of result, though. I don't know if my expectations are a little bit too high, but... Okay, let's drop it to one iteration. Okay, it is a little bit weird that the moment I enable it... Oh, I do actually call that here. Okay. That makes sense then. Hmm. Okay, is this correct? Pretty sure this one is actually correct. We do want the flat index for this. Wouldn't it be the logic and operator for row and column? No. Because if I use the AND operator, I would only filter it on this cell. But if I use the OR operator, I would get the entire cross shape. And I do want the entire shape here. I don't know if I'm doing anything wrong. So the set has flat indexes, but not rows and columns. So flat index is just going from like 2D data to 1D data. It's just like, yeah, y times width plus x. But I wonder if there might actually be. It could also be a situation where it could actually be working. It's just that I need to negate certain things. Like that could actually be the case. Maybe print A to see what's going on. Yeah, I would just need to make the matrix significantly smaller because otherwise it's going to be unreadable. Okay. We're making it a 3x3. And let's comment that out for now. What are you trying to achieve? I am experimenting with solving a Laplacian right now. Okay, let's see. Okay, wow. I did do a talk of equaternions, yes. Okay, so this should work. I've tested the solver on like a very simple case like this. I just didn't use the Laplacian constructs here and whatnot. That talk was such a game changer in my life. Hell yeah. You know, in hindsight, I feel like maybe I should have uploaded that to my own channel. But it feels weird to have videos both on like the conference channel and on my channel. I don't know. Okay, I don't know why this wouldn't work. But I'm guessing it's going to explode again. This is probably just going to disappear. Yeah. Okay. We need to print some stuff. Where's my print? Did I put it in here? Yes, that's a bad place to put that, but whatever. I think on YouTube you can do collab video with 2 YouTube channels. Yes, but there's only one channel that gets the monetization stuff. Okay, so we want to print... What do we want to print? I guess the actual values? I want to see it as a square matrix though, so I guess we'll make a new square matrix with the raw data from that one. No, it's the channel of the conference that I did the talk at. I did the talk at a, let's see, was it Game Jam? I think it's on Nordic Game Jam's channel. Okay, we have a bunch of nans. So, cool. Okay, I'm gonna print that before. Wait, that was not the line that I was supposed to move. I was supposed to move this. Okay, just to double check. Just to make sure I'm not starting out with nans. Okay, I am starting out with actual honest to God values. And then they turn into nans. Okay. I am kind of curious about the layered matrix. I don't really have a print function for those. I guess maybe I'll duplicate this. So for a bounded matrix, you can automatically get the number of rows and columns, but for the general I matrix, you have to specify. So this is just going to be count rows, count columns, matrix, and number format. Row count, column count. Okay, so now I should be able to print our layered matrix so we can actually see what's going on. So we've got our A matrix. We're gonna do, oh yeah, wait, I guess I never made a print function for that. That's okay. Okay, how big is the A matrix? It is n by n, I believe. Yes. Yeah. If we have a 3 by 3 data set, we have a 9 by 9 A matrix. Yes, which is this. Yeah. Cool. Yeah, that should do it. Oh yeah, we need to actually print that. Right. Our A matrix. Is that what it's supposed to look like? I think so. Signs inverted? Maybe. Someone said something about how the solver that I'm using expects positive values along the diagonal, right? But yeah, it's clearly unhappy afterwards. What is B initialized to, actually? Oh no, wait, that's a sparse column. And we do get value or default, which means that should be 0 if it's not there. What's a problem you're trying to solve? I'm trying to figure out why I'm getting nans after running the conjugate gradient. I mean, I guess I could just like restore a bunch of my printing. Let's bring back the prints. All the prints. Every single print. If sign is inverted, isn't it not the Laplacian? For a graph Laplacian would be L equals A minus D, not A plus D. Yeah, it could be that I need to invert the right-hand side as well. And then invert the results at the very end or something like that. But I mean, inverting the right-hand side doesn't make sense either. Okay, wait, hold on. Okay. Our residual is 0. Before we started iterating. And that seems deeply incorrect. So So it's supposed to be b minus b times x. Oh god, this is index hell. So it's summing over all the columns in A. All of that multiplied by wait, this should be row, right? Because it's a column. Right? That one there seemed a little suspicious. Still doesn't work. Cool. Neat. Or no, wait, it is supposed to be column. What? I know that I did a rewrite here. I don't know. This looks fine to me. Am I just being stupid? Oh, you know what? It could be. It could actually be that the result here is one of the inputs. So I'm manipulating the same data. Hold on. Okay. No, I guess not. I am using different things here. Wait, I didn't like mess up my toString function, did I? Count rows, count columns, row, columns. No, that makes sense. How do you embed your boundary conditions, the values you want to fix, by embedding into the matrix or by adding them to the right-hand side? Right now they're embedded into the matrix. So this variant, basically. Yeah, this is pretty much how I set it up. But it's not working. Oh yeah, and these would be positive and these are negative. I still feel like I shouldn't be getting, like, even if I had a sign wrong, I feel like the residual would just be negative, right? I mean, I guess I'll just do this just to make sure that it's not like a memory sharing issue. But I don't think that's the problem. Why? Okay, you know what? I'm gonna print the B matrix as well. Because what if that's wrong? Who knows? Right. Row count 1, column count. No, wait. Row count is n. Column count is 1. Matrices flipping x and y is so annoying. That B matrix looks fine. That looks super correct. Where's my residual 0 then? I do have 2 residual functions. I guess I'm not using this one. But I wrote this one later, so here I got this multiply row thing. Why are you passing in a result matrix and also returning it? Because my code is a living document of my past. Residual at start can only be 0 if the x0 we pick is already the solution or a is somehow incorrect. Well, x0 is definitely not the solution. A looks correct to me. But it could be that the function that I use to calculate the residual is also wrong. Now I'm lost in my code. I feel like I'm getting tired as well. Not good. Not good. Feels like the X matrix is filled with 0. Let's print it. See what happens. I guess that would actually cause that to happen. Or no, wait. I am printing that. You know, it's got data. It's fine. Yeah, it's yeah, okay. Let me let me take a screenshot and I will zoom in because this is a very tiny font and I will show you. All right. Here's our situation. I feel... Wait, why are these... Why are these all 0? That feels incorrect. Maybe it's not. That feels weird. Actually, why are these 0? That feels incorrect to me. I feel that there's... That's not... A graph is just a square lattice, right? Yes. Is a matrix reversed, not transposed, but like actually every row and column inverted? What do you mean by inverted? Because these values are properly punching out what they're supposed to. So this, the fact that these are 0 and 1 here, that's correct. But I'm confused about the far right here and the bottom. Or no, you know what? It's because I think I was expecting 1s here. I wonder if there's... Maybe it shouldn't punch out the whole thing, actually. Maybe it should only do it horizontally. I feel like it actually shouldn't do it vertically. Yeah, why am I setting it to 0 vertically? The 2 at 2, 2 is also missing a -1 on each axis, right? I think... No, I think that's correct. It does have... It's not supposed to have all the -1s. It does have gaps in a pure adjacency matrix. Because it kind of follows the 3x3 pattern. And there's exceptional behavior at the corners of these. So at these corners, there's sometimes some exceptions to the pattern. But I am pretty sure that I shouldn't clear these vertically. I'm convinced of that now. So I think... I should just remove this. I think. Holy shit, this looks good. I think this might actually be it. Hold on. So if I move this up and we tell it to recalculate, That works. Let's add another data point to our extremely coarse grid. And do another recalculate. Okay, so now it's one iteration. I believe. I think I limited it to that. Yeah. Let's do 3 iterations. Okay, not quite. Didn't quite hit that value, but wait, it shouldn't even have to seek towards these values. This should just be the right value because this is a known. Although, no, actually, I was going to say I'm limited to 256 different levels, but that's not true. It's supposed to be a float. This should just be fixed at the right height immediately. So that's a little confusing. Unless it just didn't initialize correctly. Because these are spot on, right? Oh my god. That's perfect. And so is that. Oh wait, hold on. Hold on. Is it actually working? No, like why is that one? Why is it off? What? Or no, wait, it's aligned with this one. That's gotta be it. Yeah, it's probably working. It's just aligned with this rather than the one that it's over. Oh my god, okay, yeah. So I'm not losing my mind. It's just an off by 1. Right? Hold on. Okay. Hopefully. Yeah. Cool. Okay, so we're fine. We're fine. Everything is working. Neat. Alright, we're cooking. We are getting somewhere. We are actually cooking now. So how much do I dare increase the resolution on this now? And do I dare make it in real time? That's the big question. But okay. First off, let's remove all of my printing inside of the function in case I want to make it real time. And then I want to increase the resolution. So we're going to do 12 by 12. No, wait, that's an uncomfortable number. 16. Just in case, it was nice knowing you. I have not made a tool for voxel modeling now. Okay. This is suspicious. Why is it taking this long? Because of Unity? I think this is probably on me. I think... Oh, hold on. Okay. Alright. It was just very slow, and it is definitely not converged. feel like the convergence is so bad, though. This is awful convergence. I feel like if this is the rate at which convergence is happening, I feel like just taking the known values and diffusing them and then normalizing to get like a Voronoi of all of the values and then iterating. I feel like that would be much faster. Could check the keywords matrix free smooth errors. One does not need to build a matrix. I do want to build a matrix for this though. Like, yeah, I can like probably set it up to just be like I'm averaging values or whatever in place, but maybe there's also a bug somewhere. That's more likely, probably. Let me think. Let me think. So with the change that I made that made it actually start working was that these don't punch out values vertically, only horizontally, which means we would keep some of these values. Or no, not that one. So we would keep these around. You have a profiler? Yeah. I wonder if it's like, because it kind of feels like I have a logic issue rather than anything else. Because I thought that the convergence would be much faster than this, because this was 3 iterations, right? Where's my iteration count? Yeah, 3. Yeah, it's gonna be real time in the end, so it has to be real fast. Which probably means that I'm gonna do this on the GPU rather than the CPU. But right now, I mostly just want to make sure that I have the logic right in my head. Do you have any course on C#? No. Unfortunately not. I've considered making one though. It's one of those things that I have taught C# at schools, but I haven't done it publicly. Maybe because of the mixed up signs, potentially. Okay, let's go to a 4x4, or maybe a 5x5 or something. Just make it a little bit more digestible. I do want to print the residual so that we can see the convergence. Okay, the residual for this one, it goes from 4.9, 2.5, 1.5, 1.1. I seem to remember that, like, the conjugate gradient is supposed to solve after the number of iterations as entries, I think. Either entries or one of the dimensions. But it's got to be the number of entries, not one of the dimensions, because the dimensions is just a specific construct for my use case. So in this case, it would be 25 iterations, right? I have too much garbage code in here. It's the number of rows, I believe. Yeah, but it's the number of rows in this matrix, not the number of rows in the data matrix, right? Let's do 10 iterations. Okay, residual drops down to 0.0003. Valid. What? I don't know, I feel like this looks fine. I found the initial guess of the conjugate gradient needed to be kind of close to the answer. Okay, because mine is not very close to the answer right now. Because I feel like it is converging, right? And it's not reversing in convergence. It is only getting better and better. So I don't know, it kind of looks like it's fine. Okay, this offset is really bothering me. It's probably because I'm like doing round instead of floor for the conversion. I wonder if I can just sneak in a fix for that. Where's my why do I have so much garbage code? Wait, where did I put it? It's supposed to be in here. Oh, here. I believe this should be floor. Or ceiling. Or I need to offset it by 1 in some direction. Well, it looks closer at least. I don't know if it's not quite there, but good enough, I guess. Maybe it's a half texel offset. Okay, why? I thought I had a hardware issue with my mouse, but this might actually be something else. If I tab to writer and I left click, Unity focuses. And this happens not just in Unity. This happens in it's all the time and randomly. And the way to fix it is to just right click, and then it stops happening. Why? How can applications randomly steal my left click until I right click? It's really weird. I have no idea what's causing this. Yeah, I hacked you a few days ago. Okay. I mean, that makes sense. Wait, is it only on one axis where it's wrong? No, that can't be it. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know. Okay, so here the residual is 0.33. And let me actually just recalculate this because I want to see how long it takes. Okay, that's not too bad. Let's make iteration count a variable so we can edit it. Okay. Where was I? Okay, there we go. Okay, iteration count is at 10. Let's increase that to 16. That should get us really close. That got us kind of close. Residual is 0.03. It is really neat to see the shape that this takes. I don't know, it's kind of mesmerizing. I wouldn't expect this to dip down though. I feel like this should just like taper off upwards. Because there's nothing that's supposed to pull it down here. I wonder if that's what's different if I let it iterate twice as long. Let's do this. That's weird. That was really not what I expected. What incentive does this surface have to go down? That makes no sense to me. Like anything outside the convex hull of my 3 points, I would just expect to kind of extrapolate whatever is inside. But it feels like this one is opinionated, like it wants to go down here. Why? And according to the math, the residual is basically 0 at this point. Huh. Weird. Or is my intuition wrong? Does it make sense for this to go down here? Maybe it does, and I just have the wrong intuitions about this. Is this heat diffusion or polynomial fitting? This is sort of neither. Right now I'm mostly trying to solve a Laplacian, given some fixed data on a 2D grid. So these 3 points, these blue points, is my fixed data, and then I want to smear it over the rest of the domain. Using trying to fit a harmonic function, basically. So it's not polynomial, no. Actually, I feel like there should be. I wonder if there's actually an analytical function for point data. I feel like that might actually be a thing. What would I even call that? That's like, there's a word for this. Minimal surface given points. E to the 2 pi. Hello, everybody. Wait, 2i pi. Sorry, I missed the imaginary unit. Thanks for the raid. Because I wonder if, or no, the moment there's more than 1 point. Because there is a kind of like minimal surface kernel. Like if you have a single data point, I forget what it's called. There's some kind of like minimal surface like shape. Is it Green's function? I might be thinking of Green's function. Oh, table of Green's functions. There's multiple. 2D Laplace operator. I think I'm thinking about this one. I think. Let's let me visualize it. Or no, but it can't be that, actually. There's a pretty strong flicker on my end. Is that just me or some encoding issue? Is it flickering for anyone else? This is one that I was thinking of. Why is it pointing down, though? I feel like there should be a negation somewhere here. Should it not be negative? So I wonder if you have multiple point sources, if there's like some kind of analytical way to combine these to get a minimal surface, but probably not, because the minimal surface has to be like aware of its neighbors. So I'm guessing there's actually, hold on. My solution has to be super wrong, right? 3 points should always give a plane, no? That should just be a flat plane, like the plane of the formed by those 3 points. I would assume that would be the minimal surface solution. So I'm guessing my thing is solving for something else, and there's something dragging values down. So this is incorrect. It's correctly fixing these points, but something is pulling something around in the wrong direction. But the thing that's confusing to me is that, like, where do I put the sign flips? Would it be like on these values? If I want to guess if I got a sign flip wrong somewhere? Guess I can just try and see what happens. Who knows? Maybe everything's magically gonna work out. This one has positive set to true, which I think is correct. But let's flip these values. And you know what? These should be set in the same swoop. So then both of them have to be negative, I think. Well, we get the same thing, but it's flipped to the other side. Cool. Also, this is not showing the actual values that I was using. Because these are positive. And all of these are negative. It does look like the problem is in A. Where though? Hmm. In my opinion, those twos are wrong. Why? It should be fours. I mean, not really. If it's a corner value, it shouldn't be a 4. That number tells you how many neighbors a given cell has. And this cell has 2 neighbors. This one's got 2 neighbors, 2 neighbors, 2 neighbors, 2 neighbors. 3 neighbors, 3 neighbors, 3 neighbors, 3 neighbors. And 4 neighbors. So I'm pretty sure this is actually wrong, but I don't think this is the actual day that I have. Let me double check. This is not a 3x3. Let me just revert to a 3x3. Did you derive these matrix equations using the relations that define the solution at each point? Usually helps a lot getting the solutions for each node in an explicit equation format. I should probably double check that. But it's... I haven't done the math to reverse all of those. Because it is kind of a mess to untangle all of the Laplace equations. So I did take a shortcut with the adjacency matrix. And I'm sort of just trusting that it works, but when I like intuit it, I feel like it's correct. Okay, so this looks correct. Okay, you know what? I'm just gonna replicate the actual values instead of my half-baked version. Oh wait, I should probably match the... Let's see. Okay, so which ones are... it is 0, 1, 2, 3, 5, 7. Zero, 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Here I'm using 2 and 5. And this one, I should ignore. Okay. That was the completely wrong indices. Oh no. I don't know which indices these are. Okay, so this is 0. Oh my god. 0, 3? Wait, what is the order here? It's not 0, 1. Oh, maybe it's just because it's mirrored. It's probably 0, 1, 2, 3. That's probably it, because I mirrored the UVs. Okay, so I think 0, 1, 2, 3, 4, 5. Okay, how about now? Wait, no way, it's the same, right? Hold on. No, okay, good. This is... Okay, there we go. Screenshot. Okay, so the actual values, we have a 3 here, 2, 3, 1, got a 3 here, and then 4, 1, 2, 2? Or no, yeah, that makes sense. Okay, yeah, and then 2, 3, 2. Okay. Okay. Those are the actual values, I believe. Got the same gaps. Yeah, cool. Certified, valid. Shouldn't the graph Laplacian here have every row sum equal to 0? Why aren't rows 2 and 5 following that? Because it's a combined set of equations, right? That's the way that I understand this, but maybe that is the issue, actually. So in my mind, all of these entries and these entries and these entries, that was awful. These entries and these, they are solving a Laplacian. But these two, that's just like an identity operation. So this is just stating a fact that these two are equal. Can you not do that? Or why isn't your matrix symmetric? That is a very good question, actually. That would make it not work. You are absolutely correct. That is true. That makes it not work. Because the solver is not designed to handle that. Okay, so I know what this is. Yes. Yes. Okay, yeah. I know what this is now. So in order to make this symmetric, I need to nuke this and this, as well as this, this, and this. They all have to move over into B. So basically I would, instead of 0 here, I would do minus F5. No. Hold on. Plus F5? Or wait. It would be plus, right? Because it's minus here. So it should be plus on the right-hand side. So we add F5 to 4 and 6, right? And then, oh wait, 4, 6, and 8. And then we do the same thing for F2. So we add F2 to 1. And 3. Yeah, and then we set these to 0. And then it's symmetric. And the equations still hold. From what I can see, if I'm not mistaken, you're using something called a 5-point stencil? Yes. I did look up the matrix form of that. That is pretty much what we're looking at here. And I did look it up on Wikipedia. I'm a pure math guy who works in geometric analysis. Is there any useful theory stuff I can yap about? Potentially at some point. Right now, I'm more in just like basic linear algebra stuff and trying to set up my matrix solver. But I think this is correct. I think the Miguel in YouTube chat, when he mentioned that the matrix is not symmetric, that is the problem. Or it is at least one of the problems, which might be causing these issues. Yeah. So there's two things I need to do then. For every known value, I should check for the adjacency matrix in every row that's not itself. And then for every nth value, I add it, or add the known value itself to be at that same index. I think that's the key. I think that's it. I did not mean to drop my pen multiple times. Okay. Maybe missing context, but unless your Laplacian has 0 row sums, you would expect to see new heat just popping up out of nowhere. Is it not 0? Actually, what's up with row 3? This one. Because that's got a 3, but it's got 4. Oh, that's a typo on my end, I think. Yeah, wait, why? Hold on. Or no. No, actually... Maybe I just did a typo? Hold on. Did I... That row is nuked there. Let me just take a screenshot of this again. Uh, 2, 3, and 5, 6 should be 0. Yes. Wait, so 2, 3 should be 0. That's true. And 5, 6, they are also not connected. Does that line up with my... Yes. It does look like my actual data is correct here. This one I think is correct. All of the numbers balance out. So I think it was just in my notes. Your Streamlabs donation page is down? I have a Streamlabs donation page? I have not looked at that for ages. If you do want to support the stuff that I do, Patreon is the best place to do that because they don't steal a huge percentage of stuff. If you do feel extra generous and have money to spare. Okay, but the data is correct, so cool. All right. So how do we do this? So it's basically here. We need to let's see. Oh god, the order that I defined these in is a little bit annoying here. Or no, wait, I can just... No, wait, I have the Laplacian separate. Good. That's perfect. So there's 2 things I need to do. One, I need to bring back checking both row and column. But I then need to make sure that I take these values and push them into the B column vector. So let's see, for each known value, which is going to be 2 and 5, I iterate through the grid Laplacian. So this is going to be the row. And there's n of these. And oh god, did I do XZ? I don't know which one is row and which one is column. I'm just gonna say column is probably... or no, wait, we have the flat index. That's gonna be the column. No, that's actually the row. Actually, it depends on which one. It depends. I don't know. I'm gonna call it I. Okay, so I is now stepping over here, which is gonna be column in this case. And then for every row, I check the grid Laplacian at that row and column. And also if row equals column, you know what? That I could maybe just use the same procedure to fill in these rather than doing it like this. But whatever. Okay, so let's see. If row equals column, continue. And then if the value here at the cell is non-zero, then we want to set B of row plus equals, or minus equals, I guess. No, plus equals. I'm not going to do minus equals. We're doing plus equals negative values. That makes more sense. The value that's there times the known value. Yeah. I think that's it. Okay. All right. Everybody good with this? Are we signing off on this logic? Okay. Well, that's immediately incorrect. BI overwrites? Yeah. Oh, you're thinking like... That this one... Yeah, that's true. Should I just do plus equals here then? Is that it? But they shouldn't ever overlap. But clearly that made a difference. Why do they overlap? Is that normal? Is it supposed to? But I mean, this seems to work all right, at the very least. I guess we can try bringing back our third point and increasing the resolution a little bit. See if we get our plane. Oh, 0 is all the way down there. Okay. More pixels. 12. Come on. I want to see the beautiful plane that's a little bit jagged. That is not it. This looks exactly like before. Looks like I'm having the exact same issue. This kind of makes me feel like it actually managed to solve my non-symmetric matrix. Because they should be mathematically equivalent, but the solver... Actually, is my intuition that it's supposed to be a flat triangle correct? It has to be, right? Like, that's gotta be the most... It's got like the least amount of curvature. Well, maybe it's not minimizing curvature. But I thought it was minimizing curvature. Or technically it's minimizing acceleration, right? You're solving a Poisson equation. To get the plane, you must solve the Laplace equation. I thought they were basically the same. Except Poisson equation allows you to set specific values on the right-hand side. No, wait. Hold on. Hold on. Yeah. I think you're right. Because the fixed values of the Poisson equation is not a fixed value. It's a rate of stuff. So yeah. So this is basically solving for like sinks and like heat sinks, right? Um hmm. Okay, so I feel like I'm probably mixing up the like solving the Poisson equation for specific values does not solve for specific height values. It solves for a specific rate of increased height. Is that it? So like, if I'm solving for yeah. Okay. So then my math is probably wrong. It's not, the matrix stuff might actually work. It's just that my math is wrong. Where is it? Each point has a given source sink rate that contributes to the infinitesimal curvature. Yeah, but what am I solving? Because I thought I was solving for, like, maybe my intuition is wrong here, but I thought these lines is a constraint on position, but everything else I thought was a constraint on. Oh, wait, yes, hold on. Hold on. Hold on. This is incorrect then. I think, right? Like just adding is incorrect because the thing I'm adding here is not a position offset. Here, I'm adding a, like an expected Laplacian, which has to do with acceleration, not with position, right? That's got to be the issue. Right? I need validation. I need someone to let me know if that's correct. Because the Laplacian is kind of like, this is sort of like the acceleration of thingamajig equals 0. That's what I want. But if I'm setting these to some value, yeah. So I think the mistake that I'm making is that I have something inside of the Laplace equation, and I think I moved it to the other side by just subtracting like that, which is not correct, right? No, that just is not correct, right? I don't know why I keep saying right. This is incorrect. So I think that's what I was doing. So if I wanted to not do that, I guess it would be... How would I do that? I think acceleration is a dangerous intuition to pick up here. Laplacian more or less describes the flow between nodes. Maybe. In my mind, it's just a second derivative, sort of. But it's like an omnidirectional second derivative. That's my intuition. If you want to keep the sources fixed, maybe just reset their values after each iteration. That feels weird, though. That feels like a hack. That doesn't feel like the correct way to do this. When you mentioned minus x on the other part, did you mean matrix inverted? No. No, I just meant that, like, when I move these out, I think my intuition is that I could just take this coefficient and just move it to the right-hand side. But I can't do that if that coefficient exists inside of a Laplace operator, right? Because then what used to be just a straight up offset now becomes an expected value for the Laplacian, right? And that does not seem right. Okay, so there is some kind of logic that that I need to have here. So if I were to move this out, it kind of feels like I want this offset. It should be applied here. But it almost feels like I need to, like, I want to apply this offset here, so I need to, like, multiply out all of these and then somehow work that backwards into an offset in B. But I don't know if that intuition is correct. In terms of heat, that means they act as infinite sources that can never be drained. Whenever B is non-zero, or... Let's just log B, because I think it's wrong now. You think so? Well... B... Wait, is that B? Hold on. If this is B, that is not good. Oh, no wait, this is printing X, but I'm printing it before I do anything with it. What? Oh. Okay. Row count is n, column count is 1. What? No! Writer? Why do you steal my copy paste sometimes. What? What's the motivation behind this equation? Which, at what level are we talking about? Because this can be either a very long answer or a very short answer. Well, this is B. I mean, that looks reasonable to me. I don't think that looks wrong. But yeah, I think it's my logic that's wrong. It's my math. I think I've been streaming for way too long to brain that out right now. Yeah. I also need to eat pretty soon. But we made progress. We made progress today. We have some kind of heat distribution. It's just not what I wanted, but we're getting there, I suppose. Okay. Why not use an existing implementation to guide you on what's wrong? There are some in the C++ on GitHub. I enjoy problem solving. I don't know how many times I need to repeat this, but there are so many people who are asking me. I'm not here just to get results. I'm not here just to get a finished product. I'm here to learn stuff. I want to learn this stuff. I enjoy the problem solving. Yeah. So that's why. Nothing against you. I just get this question a lot. Maybe you need a banner on the live stream. Yeah, some kind of banner that's like telling people why I'm not using AI for this. But alright. I should really get something to eat and end the stream. Are there any questions before I head off? What values do your point sources use? They use the wrong values. So I set the height based off of the vertical position of these. Wait, is it not working now? Did I break it? I did break it. Wait, what did I change? What? I just did a print. Comparing against an existing implementation to figure out what's wrong is a good idea here. I feel like the thing I'm doing is pretty specific though, and I would need to make sure that I'm actually looking at the right thing, which I think if I knew what to look for more specifically, then I think I would also know how to solve the problem in this case. I think. Someone said your donation system Streamlabs isn't working. Yeah. I just haven't used it for ages. I'm guessing there's something I need to set up. But yeah, the better way to support me is to go to Patreon. That's the most efficient dollar per dollar input to dollar output. If you want to support the stuff that I do, I would say. Wait, so it only works after recompile? Is that it? Or after toggling it, maybe? Okay, that's fine, I guess. When is the next stream? No idea. I tend to not plan my streams because I just after my burnout, I just haven't been able to, I don't know, it's stressful for me to have too many plans for streams. So I kind of just do it whenever I feel like it right now. So we'll see. I've also had this issue with my throat of late. I don't know if you can hear that it's kind of coarse. So I probably shouldn't do consecutive streams because my throat is kind of sensitive for some reason. But we'll see. I'm also not consistent on that. Sometimes I really want to stream, even though my throat is unhappy, and then I do it, which I probably shouldn't. Okay, maybe the last test. I want to increase the resolution and see if it gets stuck or not. I don't really have a command for a summary or context for what we're doing. Maybe I should put that on screen somehow. Like a progression tracker type of thing. Do we dare going to a 128 by 128? Do we dare doing that? 10 iterations? That's quite a lot. Let's do 4 iterations. Or maybe 2 iterations. I don't know how far I dare to go here. 2 iterations. Are those red numbers in the matrix even correct? I think so, yeah. Your code is working correctly, you just expected something different? Yes, I think that's the problem. The problem is my math, not my code. Yeah, because when I move those coordinates to the right-hand side, I thought I was telling it to use a specific offset, but I think I might be telling it to use a specific Laplacian. And so then it's seeking towards the wrong value, I think. Yeah. Someone on our project brought ShaderForge into the mix back then, and that was the moment I finally understood how shaders work. Today I write STFs and complex post-processing shaders. Hell yeah. Glad to hear. Assuming you're doing it where you want to do it, and that you're not like under threat or gunpoint. Well, we're 1 minute 20 seconds. It's thinking. Maybe I'm gonna start making some tea water. Just gonna put on a kettle. I'll be right back. It's still going? Oh, goodness. I put the numbers too high, probably. Progress bar would be nice. That would be nice. All right. This uses finite elements? Yes, I believe so. That's just like any discretization, right? Add your Tetris game into this project. You know, I actually have. This is the Tetris project, so it's kind of the other way around. I added this experiment in my Tetris game project, so it's just stuck. This is where good sparse matrix support is important. Yeah. I'm trying to think of. Yeah, like I think there's a certain functions that I have right now that don't take shortcuts that they can take with sparse matrices. I think my matrix multiplication does not take any shortcuts right now. Hey, Salad. Hello. Hey. Wanna talk the stream? Come on. Yeah, come on, buddy. Yeah, come on, buddy. Yeah, coming up. What? Big baby boy. Hello. Hello. Are you feeling better? You feeling okay? Yeah. Oh, this is Salad. This is not Thor. Let me. Salad deserves full screen. Look at this man. Look. 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 Hello. You're kicking me now. How am I supposed to pet you when you're kicking me? Yes, you can. What? He started purring and that's when he left. Like, how does that make sense, buddy? It's still not done. Did we... Is this an n cubed type of situation? And we cubed too close to the sun? How big did you make it? I made it 128 by 128. And I lowered the iterations from 10 iterations to 2, I think. Yeah, I think 128 is kind of spicy. Have you seen Star Wars Maul the Shadow Lord animation? It has a lot of action. I don't think so. I have no idea what that is. Okay. Maybe I'll give up on this. It's been 8 minutes. I think I'm gonna have to do a few performance passes on this before I can actually use it. Because right now I'm not using optimize like matrix code at all. And it's not parallel either. This is like single threaded. But yeah. Thanks for joining, everybody. Um I don't know if I have anything to plug. I don't think so. Bon appetit. Thank you. I am actually very hungry. Oh yeah, well, I have a Patreon. If you want to support the stuff that I do, which is violently inconsistent. I am very inconsistent in the work that I do. But if you do want to support the stuff that I do, whatever it is, then you can do that on Patreon. It's the best place to support me. It's the most amount of like percentage of your money goes to me rather than the companies. Yeah, it's a really good place to do that. If you have the money to spare. Otherwise, pretty much everything I do is always freely available. I have basically 0 exclusive content on my Patreon. I should probably change that, but so basically, what I'm saying is that it's not worth it to support me on Patreon. In terms of expecting any kind of reward. Yeah. All right. Thanks for joining, everybody. Don't know when the next stream is going to be. Maybe tomorrow. Maybe in 2 days. Hopefully in 2 days. I don't know if I should stream tomorrow because I can feel my my throat is really unhappy. I've been talking way too much. All right. Yeah. Okay. That's it. Bye bye, everybody. Thanks for joining.